So here's an example in the data science class, the very first time where we import two different data sets, two different data frames, and use information off both of those. In the process, we'll have to tidy up each data set and then use data from each one of those data sets and combine them into a single graph. So the question is, what is the relationship in the yearly trend between the number of death penalty sentences and the number of actual executions? As you might imagine, more people are sentenced to death than actually are put to death in a year. So you can see how the data set is laid out. These are the number of sentences over the years, 2019 all the way to 1977. In 1977, the death penalty was reinstated, presumably with some fixes, after a 4-year moratorium on the death penalty in the country. We're going to look at the trend, and the trend we're looking for is the trend between the actual number of executions, and you can see in this data set, if you scroll down to the bottom, you'll see that the total number of death sentences in 2019 was 34. You can see the actual number of executions by year down here in this total column. So we want this column, and then we want the year. Those are the two columns that we want to draw our time series graph from 1977 to 2019. The other data set gives us a listing of every individual who's been put to death by the U.S. death penalty in some state or some federal body since 1977, when the death penalty was reinstated. You can see Gary Gilmore there. He was the first one after it came back, and he was put to death in Utah by a firing squad. If you scroll over to number of victims and you scroll all the way down quite a while, you'll see some other individuals that you might be familiar with. Usually the higher numbers are the ones where you recognize them. So here's John Wayne Gacy. Going further on down the list, so here we go, 129. Who could this be? As you scroll over, you can see this was the Oklahoma City bomber, Timothy McVeigh. But there's about 1,500 if you scroll down to the bottom, since 1977. So these are the actual execution dates. Notice the piece of information that we're after in this data set is that year right there. So one of the things we're going to have to do is to separate the day, month, and year from that date so we can get a hold of the date. So that's the executions database. So here's our strategy to join the two data sets together. The executions data set has the execution date with month, day, and year, and then the first name and the last name of the person executed, their race, sex, state, the execution method, and several other fields. The sentences database has a listing of all of the groups that have access to the death penalty, regions like South, Midwest, and so on. The military has a death penalty. There's a federal death penalty, and each state, many states have the death penalty, but not all. And then there's a total column in that data set, and this is the one we want to link to, and the year. So we want to join the year of executions to the year in sentences. So our first step is to break apart the execution date by day, month, and year, and then we have the year separated out, ready to be linked with the year over here. And then the next thing we're going to do, since each one of the records over here is an individual execution, some executions occur in the same year. So we want to do basically a subtotal command to add up all the executions by line that occurred in each one of the years. And that would give us the individual year and the total per year. And then that's what we're going to link to the year field in the sentences data set. And so let's take a look at the code that we would use in order to combine those data sets and come up with the time series graph over that period, comparing executions and sentences. Here's the link to the executions database. The first thing you want to do is to read it in. So you would read in a CSV file and then convert it into a frame. And then here you can see just the tibble here. Here are the dates, execution number. It's got a bunch of NAs in here if there's missing data. So it's not in a very useful form. The next thing we're going to do is to separate the date, the execution date. Now in this command, we're going to get rid of the execution date and replace it with month, day, and year. The separator is a slash. Then instead of printing that whole messy table, we're just going to select a couple of the relevant fields like first name, last name, and then the 3 month, day, and year that we wanted to have. So let's take a look at that. And then there you can see it. They've got first name, last name, and then it has successfully separated the execution date by month, day, and year. You'll also notice that there's a couple of things we need to fix. We have these numbers that are declared as characters here. We have multiple dates there for the same year. In the end, we just want to say 1979, and in 1979, there were 2 executions. In 1982, there were 2. 1977, there was 1, and there are none in 1978. So this is what we'd like to see. Okay, in this next one, since we have those duplicate dates, what we're going to do is we're going to group by year, and then we're going to count up the number of records, individuals, that were executed by year. And when we do that, you can see there they are. Every different year that's listed in our database and the number of executions that year. However, you see there's a row for every person executed, and that's why there's about 1,500 in there. So what we want to do is just get rid of the duplicate ones. So that's going to be the next step. And this code right here is going to get rid of the duplicates, to select the distinct records in that frame. And if you take a look, you'll see that now we only have 1 1979, only 1 1982, 1 1983, and so on. And then these are the frequencies total. We have 31 plus 10, 41 rows, because we have 41 years in our frame. This last piece is we're going to convert each one of those non-number columns to real number columns. So we want both year and count to be numbers. And if you'll notice at the top of the columns, they're now doubles. Doubles stand for real numbers. All right, we're going to call this executions before graphing, and then we're going to move over to the sentencing data set. You can get the data if you go to that website right there. First thing you want to do is to read in the CSV file, and then this is what sentences looks like. We saw it earlier. Notice the years at the top. This is the one that we'd like to transpose. So that's what we'll be doing next. Pivot longer and pivot wider are the 2 different commands we do in conjunction, which lead us to the transpose. So let's take a look at what this looks like. Let's print it. And now when you come up, you'll see that those years that were the top row are now the leftmost column, and all of those different geographic units there or otherwise, those are listed across the top. So what we want is the year column, and we also want the total column. Unfortunately, we can't see it here because it's off to the right of the screen. So we're going to select year and total and print those, and we're going to arrange by year so that we'll get those dates in ascending order as opposed to descending order. And after that, here you see it. We have each date listed individually 1 time and the number of sentences in that year, death penalty sentences in that year. And notice again that before we join our 2 data frames, we need this to be a real number just like the other one. So that's the purpose of this next piece of code. And then notice it has changed the column of each. All right, so we're going to call that last tidy 2-column data frame sentences before graphing. And then in line 63, we're going to group them together, the sentences before graphing with the executions before graphing, and we're going to link those 2 tables, those 2 data frames by year. That's the only thing that would link them. That's the purpose of this command. And so when we link them, join them together, there you see it. You have year and the count for the sentences, followed by the count for the executions. Now, we didn't have any data for 1978 for the executions. There weren't any, so it threw in the NA. This next line will convert all those NAs to zeros, as you can see here. And here's the last piece of the puzzle. We are going to draw this graph using ggplot, and up comes our multiple time series graph. Along the bottom, you've got the years from 1977 up to 2019. And on the vertical axis, you have the count, meaning 2 different things. In the top graph, it's the count of sentences, death penalty sentences given out. And in the bottom graph, it's the number of executions that occurred that year. And so now it's time to talk about the trend a little bit. It looks like after in 1977, after the death penalty was reinstated after a 4-year moratorium. The number of executions started off slowly, but then eventually went up year after year until it reached a peak in about 1999, and then has slowly declined down to less than 25 every year in 2019. Similarly, if you look at the sentences, beginning in the very first year where it was legal, when it became legal again, we had, close to 140 death sentences awarded in that first year. And those gradually increased over the years until you see the peak here at about 1996. And you can see the number of executions has dramatically dropped, and now it's under 50 as well every year. There is data on the executions data site where you can actually go and see if that trend that we've observed for executions is continuing. So I hope you enjoyed this example of linking two data sets and using the information that we need from each of the two data sets to see an interesting relationship that maybe we've never seen before.